Hello. Hi, everyone. Thank you for joining us today. I am Rob Parrish, the Director of Product Management at Treasure Data, and we're excited to speak with you about our latest open source project, DIGDAG, a new solution for workflow management. First, before diving in, I'm going to briefly tell you a bit about where Sada and I come from, Treasure Data. So Treasure Data is a Series C company with hundreds of customers worldwide. We just launched a new category called Live Data Management. Our goal is to help you make all your customer data connected, current, and easily accessible to the people and algorithms that drive your business. With it, our platform provides a suite of technology and applications that help you to unify disparate data sources, perform advanced analytics, and take action on those analytic insights, operationalizing them into your business. We are a strong contributor to the data and analytics open source community. The projects listed here in the middle are the ones that we either created, such as FluentD, Bulk, and MessagePack, or contribute to, such as Presto. And we work great with Amazon Web Services. The majority of our customers run core aspects of their business on AWS, and together we integrate seamlessly with our analytics solution for these customers. So on to our core topic for today. I suspect many of you in the audience are responsible for managing a modern analytics application or looking to build one. Applications ranging from marketing campaign optimizations, personalizations, churn analysis, churn detection. These are projects that will likely utilize key parts of the AWS ecosystem. Shown here from the S3 object store to Redshift as your team's analytic data warehouse, EMR for data preparation or machine learning in Spark, and Aurora as your application's backend. And when you begin to build, you start with a series of scripts and SQL. Maybe you use cron jobs to automate the processing and handle dependencies. But pretty quickly, even for small and medium-sized teams, the system quickly becomes very complex to manage. Some issues that people see: cron-scheduled scripts running in an unexpected order. Handling errors become complex as it's hard to determine where to start your analytic flows. Logging happens across multiple different environments, and so making debugging a big pain. And then collaboration becomes complex, particularly when bringing on new team members, in large part because the overall flow and association between tasks is unclear. And of course, that's why many people have started to use workflows to manage as a core part of managing their analytics processing system. In short, for an introduction, a workflow is a way to define a separate processing recipe from the underlying details. Those details include the code, the environment, the data. And in doing so, it provides a high level of abstraction of the overall process being completed, as well as a record of what environment that process was completed within. In the hypothetical example you see here, this workflow is orchestrating a chain of dependencies across 4 different systems from left to right. It's important to note that the processing is not happening in the workflow engine. It's only orchestrating the processing and data flows that occur elsewhere. A common workflow may involve these steps. First, you have to ingest data, such as application logs or ad impressions. You enrich and clean that data, removing bot access, adding geo information to IP addresses. Then you likely produce a model based on that data, some analytic insight, which could be the results of an A/B test, segmentation analysis, or otherwise. And then finally, you want to load those insights back into your production systems so that you can utilize those insights for your product or system. For a more specific example, let's say you wanted to utilize data from your web logs, a production database, and marketing campaign data. Bring it together in S3, clean and process it through EMR, prepare data sets in Redshift that then your data science teams will use to run analysis, build models that may result in recommendations ready to be accessed for your customers of what items in the shopping cart or items they used to have in the shopping cart that you want to recommend or other products they may want to buy. This can be quite a complex process to manage. And you want to update it regularly so the recommendation is as fresh as possible. To manage exactly this type of flow, we created the open source project DigDag. DigDag is a workflow engine designed for simplicity, extensibility, and multi-platform support. It's language agnostic, so application developers, data scientists, data engineers with different tools, chains, and needs can use a single unified workflow engine. And it's very easy to get started. You download the binary, and you can get started immediately on your local machine. But setting up server mode and running workflows in the cloud is quite easy as well. One Treasure Data customer that is using DigDag for workflow management is Packlink. Packlink is an online platform providing cost-effective package delivery solutions in Europe and internationally. They've turned to DigDag to help them manage their analytics processing flow shown below. Every part of the diagram that's represented in yellow, so the bulk ETL, the cleanup, analytic steps, deployment of those insights, are managed by Packlink using DigDag, hosted by Treasure Data. And you can see that based on the systems that the workflow operates against, they are focused in large part on delivering value to their sales and marketing teams for personalized marketing campaigns and optimizing sales performance. Pierre, Packlink's head of business intelligence, put it this way. Using DigDag, I now feel confident in my ability to manage complex analytic flows, from ETL processes to transferring data, to analytic steps for running attribution and cohort analysis, to deploying those insights back into the cloud systems my company uses to run our business. It's enabled us to get out of refreshes of those insights more timely for our analytic consumers, sales, marketing, and the executive suite. I now feel confident each night our analysis will be completed as expected. So with that, it's now my pleasure to introduce Sada to go into more details about DigDag and how to use it.
Okay. Thank you. Thank you for coming here, and thank you for being interested in this system, DigDag. My name is Sadayuki Furuhashi, one of the co-founders of this company, Treasure Data. I'm working for this company to build the cloud-based data warehousing solution as a service and ETL frameworks around it, and also the connectivity to the data sources around it. I'm also an open source hacker, actually. I built these tools as a open source products. You may already know about them. MessagePack is a binary-based data object serialization system. So it's like JSON, but it's binary-based, so faster and more compact. It's used in like mobile applications or some major mobile messaging applications. So you perhaps are using it currently. And Fluentd is a data collection system, which is used in like sensors and also the cloud platforms. Actually, this is a part of Google's cloud platform, so you are also probably using it. So I think current question is that why we created DigDag, even though they are open source tools and also similar commercial tools as well. A short answer is that they did not match with our requirements. Specifically, there are three problems, actually. One is that whenever we create a workflow and change it, the result of the workflow will change, of course. However, because there were no change logs of the workflow, we could not track why that happened. So one problem was that one day, a daily report changed. A value spiked. It was good because it shows beta value. But we couldn't find why it happened. Actually, the problem was a bug in the workflow. That may happen because the workflow becomes very complicated. But because of lack of the change logs, we could not find that very quickly. So it was a pain for the workflow management. Another problem is that the workflow itself depends on a server's environment a lot. So one day, machine learning script wanted to use some libraries like Python, Pandas, NumPy. That's good. So yeah, we installed the system. We installed the packages on the server. And the workflow worked on that day. And we needed to upgrade the system. But of course, they depends on the particular versions of the libraries and depends on some other components installed in the server. So it was tough to upgrade the system. Plus, whenever you want to run the workflow on your machine or actually my machine, I needed to prepare everything on my machine. It's tough, and which means that only one person or several persons can join the development of workflow. So it prevents us from having more collaboration between the data analysts, data engineers, and marketing, actually. And the other problem is that the scripts getting harder and harder to understand. So one example is that actually our customers and also us, we are using some other workflows, actually. And they were written in entire Python scripts. And as we add more steps or tasks there, it became harder to understand. And there are many, many tasks, actually hundreds of tasks, depending on each other. So without having like modulability or actually simpler interface to understand that, it became harder and harder to understand. But we want to encourage more like, collaboration between the engineers, data engineers, and also data analysts. So they were the problems we had. So DigDag solves using these three concepts. One is having parameterized modules. So in DigDag, a task will use a operator. Operator is a step to run something particular, a single job, like running a Redshift query, or creating email cluster, or running Python scripts, or running shell scripts. So that is a module. And so one module does one thing. And you can customize the behavior of that job by using parameters. So it's a generalized operator. Next step is that we group those operators into a nested task group. So task group can group the modularized steps into larger module. So for example, one step will run a Redshift query, and then copy the data, unload the data into S3, then run EMR jobs. So we can think that the three steps as a single module to do some machine learning on EMR. Then next step is to load the results back to our system, production system. We can think that is another step. So there are two nested groups. Using this way, we can easily understand the workflows. Even though you are not the developer of the workflow itself, we can read the code. And because there's a commit log, it's also easy to track the changes. And next thing is actually important for the production workflows. For each steps, we will produce some intermediate data. And DigDag makes it possible to validate the results for each steps. So this step should produce at least 10 rows, for example. If that is less than 10 rows, something's wrong. So the workflow aborts automatically. So with that building up, we can get results, and we can think that the results is always correct. So we can build trust on the results. Every time when there's a results, it's trusted. It was important for us to build, to think about next actions based on the data. So here's an example of the actual workflow definition. So as you can see, DigDag uses YAML format to define a workflow. A task, a name starting with a plus sign is a task. For example, here there are two tasks. Task 1 runs a operator called TD. TD means actually Treasure data. This runs a query, SQL query on Treasure data. Then once it's done, runs the next query. So this is powerful for developers because you can use Git and also any other tools you already know. It's also possible to generate this format automatically. So it's powerful. At the same time, this is straightforward enough for non-tech guys, actually. Because you can choose one operator to run job and then specify some parameters. That's it to run a single task. So our story is that our marketing manager actually tried DigDag and learned it in a day, in a single day, and then created a demo. So it's a good story. So let's see more about the internals. So first, operators. Operators are important because one operator does one single job. So there are operators like this. Redshift operator runs a Redshift query. EMR operator runs a EMR jobs. S3 wait is an interesting operator to build a production pipelines. It waits until a file is available on S3. So for example, you have a data collection system. It will put the file every day. Then workflow wants to run when the data is there. So S3 wait, using S3 wait operator, as like the right example shows, it waits until the file is there. Then next step is to run the actual analytics. And some other PostgreSQL operators and storage data operators and mailing operators. Actually, there are more, such as like BigQuery operator, Google Cloud Platform operator. So because data is on any clouds or any data sources, extensibility of the operator is important. So what DigDag does is that we use plugin SDK so that you can write plugins and you can release the plugins as open source projects. Then you can install those plugins into DigDag to extend the functionality of DigDag. So one example is to have Slack operator. So open source community developed it. So operators are good for typical operations. But of course, at many times, you need to do custom work. So DigDag also supports scripting operators like shell script operator, Python operator. But downside is that scripting operator easily depends on the server's environment. It depends on some specific library or specific command on the server, which is not good to support. So DigDag has native integration to Docker. This means that with this configuration, image Ubuntu 16.04, this downloads the Ubuntu OS image to run the task, and task runs in the Docker container. So the command always runs within the same environment. So that things will be always reproducible. And loop and parameters. So for example, this operator, TD for each operator, runs a select statement on storage data, then gets the results. And for each result rows, loops the subtask. So in this example, it gets an active user list using a SQL, and then for each row, sends an email for using the email operator. And parallel execution. So within a group, you can set an option called _parallel. If that is true, subtasks in the group will run in parallel. So grouping is a very essential concept of DigDag. So before having grouping, everything is flat like that. And there are many arrows, many dependencies each other. It's hard to understand what's happening there unless you understand all arrows. But with DigDag, that will be grouped like this. So first, you ingest enrich data and data modeling. And within data modeling, you have learning task and basket analytics task. And within learning task, you will run machine learning steps in parallel. So that is easy for understanding and makes it possible to collaborate between data engineers and analysts. So again, DigDag brings those best practices of software development to the workflow application development. So let's see the actual demo, how it is working in production. So in this example, in this demo, I will show you about this workflow. So first step is to load data from Facebook ad and Amazon Aurora and Apache. For like, Facebook ad is for like impression logs. So someone clicked this ad, and this user clicked this ad. So this ad is clicked by like click for 3 times, and this is for 10 times, like that. The Amazon overall includes like user data, user attribute data, and Apache includes some access logs. Then collect everything into Amazon 3 as a table format using Troja data, actually. So I run some queries using Troja data so that we can analyze data on S3. Then put them into AMR to do some Spark application, to run some Spark applications. Then do machine learning and put the results back to Redshift. Then a application uses that data to provide recommendation and location-based suggestion. Okay, let's do the demo. So here, this file is the workflow definition file, demo.dig. And here I run the command, digdag, run demo.dig, run. So here started the workflow. So this takes a bit of time for a while. So this definition first runs this task called setup. This calls a table on Amazon S3. Then next step is to ingest data from S3 for the access logs from Apache, Facebook ad impression logs, and the user information from Aurora using MySQL. Then this ingestion is using S3 wait operator to wait until this file is ready. This file includes parameter like this, so that this workflow can run every day. Then next step is to use TD load operator to load data to our Troja data S3-based data warehouse. Then next step is to run some queries to enrich the data, like joining or cleaning up. In this example, we use 3 queries: IP location to user, item to click count. This says this item is clicked for 3 times or 5 times from the logs using group by query. So for example, this query is item to item count. This is like that. So this workflow definition file and this query definition file are packaged together into one project. Then here, item to item count, yes, this query is running. And those 3 tasks run in parallel. As you can see, they are running in parallel here. After that, so here, data is prepared on S3. Next step is to run a EMR operator here. So in this demo, I'm using an existing cluster. So here's a prepared cluster in advance. And then this digdag is submitting those 2 steps into the cluster. One step is to create recommendation data. And the other is location-based, actually IP-based recommendation data. If you use like this operator creates a new cluster and runs the steps, and then shut down the cluster at the end. But in this example, I used the existing cluster. At the end, we run those copy command on Redshift. So this means that data is prepared on S3 using AMR, using Spark. Then I put the results using copy command on Redshift so that applications can use it. So let's see, this will take a bit more. Something I should say here?
Maybe you can speak to the date parameterization that you're using in your workflow.
Data parameterization, like session here? Yeah, so in digdag, there are several built-in parameters. Session date is one parameter. This is the time when the workflow runs. When you schedule the query, schedule the workflow, it automatically increments to the next day. And you can also define some parameters as well. So this export is defining some parameters. So in this case, I defined TD database parameter so that it points this database. So this parameter is actually used in this TD operator. So in this case, this TD operator uses a database called DigDag demo today. So for each run, it creates a temporary database and runs some queries within the database and creates tables on that database. So every day, it creates a fresh database. So oh, yes, finished. Great. So at the end, actually, it runs Redshift operators here to copy the data to Redshift. So let's see the results. So is this connected? Yes. So first, I want to see this recommendation table. Yes, here. So someone bought item 281. People who bought this item also bought those items. So by running this query, you can build that recommendation. So data is there using this workflow engine. And another thing is that location data. So someone is accessing from this IP, 196.4. something. Then previously, people coming from this IP, this region, bought that item. So we can build that kind of suggestion using this workflow. So now you can, I think, understand how to build the recommendation engine using this workflow. Let's see another demo. So I say that there's a native integration to Docker. So in this workflow, I'm using two tasks. Ruby, first is native Ruby, and second is from Docker. And this operator is running a Ruby method defined here. This is showing a version of the Ruby. So first Ruby does not have option to use Docker. So this uses the native, this machine's Ruby. On the other hand, next step is using Docker. Actually, on this machine, I think this has Ruby 2.3. So this first step should show 2.3, and the second step will show 2.3.3. So dig that, run here. Here we go, like this. So let's say if you have some machine learning data, operation image, you can install like Spark or Pandas or NumPy. We don't installing that on your machine. You can just specify the image of the Docker, and that's it. Yes, let's see the conclusions.
Thanks, Sada. So yes, so thanks, Sada, for the demo. One of the pieces that he didn't speak about in the demo is actually, so with this, when you start up the server mode and you deploy, you can, with a simple command, digdag push, you can deploy that entire project to the server. And once on the server, there's a web GUI so that you can go on and see the status of your workflows that you've deployed, past sessions, rerun sessions, see metadata about the operation of those workflows, find logs associated with that. So that's a key element as well that we aren't going over today, but is available and discussed in the documentation as well. And so we created DigDag to support our customers and our business. We host it for our customers so they can start creating and managing workflows without DevOps and to reduce the overall time to get started. We have numerous customers already using it for scheduling, processing flows across AWS, running data loads into and out of Treasure Data, and generally organizing their analytic processing flows. As such, if you want to become an open source user of DigDag, you can trust that we'll be continuously putting the lessons that we learn when using it with our customers back into the open source project. We've already put lessons learned from maintaining a 24/7 uptime system and having handled over 100 billion queries into our product over the last 5 years. So thank you very much. I hope you'll come by to learn more about this project and get involved. If you want to become a user, there's a user email list that you can sign up for on digdag.io. And this is specific for DigDag open source community conversations. Also, please feel free to stop by Treasure Data booth 1818. You can ask us questions about DigDag. We're hosting a party tonight at Tao Nightclub, and would love to see you there, co-hosting it with Chart.io and Logs.io. We will stay up here for a little bit to answer questions. If you have any, you're welcome to go to the microphone as well. Thank you very much.